I'll go ahead and introduce Mark Hinkle, who's going to moderate the panel tonight. Mark is extremely influential in the technology space. I've been friends with Mark for a long time. In addition to being incredibly smart, bright, he writes a newsletter. It's read by 250,000 people, at least 250,000 people. I think that number's increased since you last gave me the number. But anyway, he reaches and influences a lot of people. Most importantly, he's a hell of a nice guy. He's a hell of a nice person, and I'm honored to be friends with him. So when he agreed to moderate, I was flattered. I was extremely appreciative. So Mark, thanks for agreeing to moderate this panel tonight. Helps to have someone that's been in the space and understands the AI, subject matter at a really, really deep level. Thank you to our panelists. You're some of the best people, most knowledgeable people in the world on this topic, and thank you for being here with us tonight. So with that said, Mark, come on up, get us started. I know, everyone didn't show up to hear me blather on, so thank you all for being here.
Thanks, Todd. All right. We are going to start with an introduction, but I want to say that I had used an app called Gamma to make all of these presentations. There's an Easter egg in this slide. I didn't put it there, AI did, but if you find it, I find it very, very funny. So, yeah. Do you see it? I did not put it in there intentionally, and I don't speak Japanese or whatever kanji characters they are, so there might be bad words in there that I don't know anything about. So the joke is on us humans from AI. I'm really excited to talk to you tonight about AI and what we have to look forward to in 2025. We have a really, really interesting and diverse panel tonight of folks with lots of different perspectives. But before we start with the intros, just to sort of level set with the group here, I just want to know a little bit about you so we can inform our discussion. So how many folks here use ChatGPT? Okay, easier. How many people here don't use ChatGPT? Okay, that's cool. How many people here are building or using AI in their daily job today? All right. How many people would consider themselves knowledge workers? Okay. How many developers? Any data scientists? All right. Okay. I would fall into none of those categories. I'm comic relief, so I'm the fart guy, by the way, if you didn't see the Easter egg. So what I want to start with is I want to introduce you to the panel. We have 3 different segments. We're really going to talk about what this means to us as a society in our jobs. I think a lot of us are really worried about, anything from am I going to keep my job or to are the Terminators coming? I think that's the gamut of that, how it's going to influence our lives. We're going to talk a little bit about what we think the future holds, and I think it's good, but I'm going to let the smart folks, remember, I'm comic relief, smart folks. We're going to start with them. So I'm going to start with, at the very far side, we have Sachin from Fidelity. He is in charge of their AI search platform at Fidelity, and you folks, the microphone, if you want to say anything additional, oh, you have it. I didn't see John has it. If you want to add anything to that, we're going to go all the way around the horn, but really excited to have folks who do real things with AI here today. Next, we have Bill here on this side. Bill is, I'm matching that. So we'll go to John. John is next to Sachin. John is the director of the AI Master's Program at Duke, and he's also an entrepreneur with a product called Inquisit that's very cool. I like folks that are smart and they do startups because I do startups, but I'm not smart, so I like to see people breaking that trend. We have Fran, who's next to him. Fran is a DevRel manager at Google. I've known her for a long time. She is an open source contributor for Node.js, where we got to work together not so many years ago, or many years ago. It's been a while. And she has decided to move from New York City to the Triangle area, so I'm happy to have more smart people. And last but not least, Bill Higgins. Bill is the VP of Platform Engineering and Open Innovation at IBM. And the four of them are going to help us answer some of these questions. So thanks for being here tonight. I'm really excited. What we're going to do is we're going to go down through, we're going to get different perspectives, and at the end, we're going to do some Q&A. So if we don't hit on anything you're interested in, save your questions, and we will definitely want to answer them. So let's start with, I'm looking up there when it's in front of me because I don't have my glasses on, so the 4-foot letters are easier to read. You know, I'm going to start with John, because John is, you know, educating people in the master's program on what we see the future for roles. Like, what are you telling your students what are you preparing them for as they leave your AI program? Or
yeah, that's a great, good. Somebody said good luck.
Good luck.
That is what we tell them. So I'll take a little bit of a twist on this question. It's something we think a lot about in kind of education, because obviously AI is changing not only the nature of education, but also sort of what we need, the world we need to prepare our students for is going to look very different than it looked 2 or 3 years ago. And I think that one of the key things we're going to see is kind of a return of the importance of the soft skills. There's sort of this pendulum that swings between hard skills, soft skills, kind of focus in higher education at least. And for a while it's been in the hard skills area, and I think we're going to see that really start to swing more back towards the importance of soft skills. What do I mean by soft skills? I don't even really like that term, but things like critical thinking, problem solving, analytical skills, those are sort of uniquely human skills that I don't think we're easily going to replicate in AI. There's always going to be a need for creative humans with high problem solving skills to drive AI. Even if we do end up someday having a workforce consisting of, let's say, 80% AI agents, there's still going to be a need for humans to lead those. And so I think we're going to, in sort of the education space, we're going to start to put a lot more emphasis on how do we teach things like problem solving or critical thinking, not just sort of, teach them kind of the next programming language or memorization of facts or so on. And that's something that exists in pockets, I think, today, but overall, and if you look across higher education, I think we're not necessarily doing a great job today teaching those things. So there's a little bit of a twist on your question, but
no, I think that's a really good twist. I think that you hit on something really important. In almost every survey I see of the #1 skills for the upcoming years from McKinsey, the World Economic Forum, critical thinking is the #1 thing that they mention, and I think that's spot on. So let's go into let's get your perspective on this, Fran. If you're mentoring, you have a team at Google and you're hiring for it. What are you looking for how is it affecting your teams? I know in the news today or yesterday there was one of the other FANG companies talked about there will be no more mid-level engineers. I don't believe that in the same way that Mr. Zuckerberg said it, but he's the other Mark. He's not nearly as important as me. But what do you think about that? Like, what's your perspective?
Yeah, when I hire, I'm really looking a lot for those hard skills. Know your stuff, know what's underlying it, know the math behind it. Don't just hand wave at it, like really get deep into it. But then I want people who, in addition to that, embrace the change, who are excited about things changing and who are open to new ideas and excited about pivoting.
Yeah, cool. Yeah, that's great. How about we just move on to, we know what skills, I'm not going to ask everybody's opinion because we have some other stuff, and I have one that I really think the next question is set up for Sachin is, there's so much AI stuff, old software that's now AI enabled, new software that really is AI, and machine learning that has now been relabeled as AI. What do you, as you see Fidelity, or just in general, you've been at Fidelity, you've been at Goldman Sachs, you're a long-term technical manager. And for the record, This is the opinions of Sachin and not for Fidelity. They're in the financial space. I used to be a financial broker, so I like to put that.
I need to say it, not you.
Oh yeah, you got to say it. Sorry. But what do you think's enterprise ready? Like, what do you see among all the technologies out there that is the kind of thing that you would build, what we call enterprise grade services around?
Yeah, so again, right, disclaimer, all my personal opinions, not of my firm. So I think mostly we are talking, when we say AI, right, we are talking now a lot in the context of Gen AI stuff, right? So in terms of like use cases, the typical use cases that you see that get implemented across most of the enterprises are, I think that I can name three major ones. One is your co-pilots for coding. So using GenAI for coding, there is the information retrieval and search, which I'm focused on, a very typical use case, and then generation of new content. So your marketing, social related content. So I think those are kind of the usual typical use cases that you start with. You kind of do POC and you want to experiment with it and check out which of those really apply to your use cases and all. But just from the, like, I'm in applied AI, so my thought process is that how can I use this AI as a tool, as a technology for any of the use cases, and looking at any of these, whether it is the models or any of the products, is mostly, when I'm looking at it, it is all thinking about first, like before even we get there, right? If you don't have, if you are not identified proper use cases which are high impact, which have measurable ROI, nothing usually matters. So I think that hard work of identifying use cases which have the right impact, you can measure the ROI is important. But once that is done, then looking at the products and selecting the tools and all, it is all about now figuring out like things like, are you able to explain what AI is generating? Are you able to, do you understand how these models were created? Do you understand the security and the data privacy and other things? But I think that, like, my mind is always about, like, how can I use these tools, apply it, and then what the usual considerations around using any of the technologies. That is what I usually, those are the things that are my considerations.
Cool. Yeah, so everybody just saw me type my password that I will be changing later. 25 years of not changing it. Just kidding. Yes. All right. So let's go to, Sachin was just talking about what they think is enterprise ready. Let's go to Bill. So Bill is at watsonx, IBM, and they are building, next generation AI. They've been doing it for a long time. What are the kinds of tools that you think are, what's your primary solutions that you're focused on today? What are the underpinning? You're the infrastructure guy. You're doing the plumbing. What are you building these days?
Yeah, so let's see. When ChatGPT came out in November 2022, it was pretty interesting because we sort of had, Gen AI in the roadmap for, I think it was 2024, and then when that happened, it got shifted up. And really, what a lot of the initial focus on was we had decided to use an open source based stack, which is why we're at this meetup here. And a lot of the open source that had been created that was really high quality, like PyTorch, I see Sadov out there who works on PyTorch, was really built for these super high-end data centers for companies who effectively had infinite money. And so one of the first challenges was, how do we just make this stuff work in normal data centers? So I remember there was a pretty interesting PyTorch performance bug that only occurred when you took it off the meta kind of alien networking onto normal networking. And so a lot of it was just making it work in normal data centers. But I think at this point, the open source stacks for inference, for training, and for tuning are getting really solid. And so now I think those are starting to become more mature. Like our inference is built on a technology called VLLM, which originated from Berkeley. I don't know if any people know that. But for instance, that's now moved under open governance at the Linux Foundation, which we thought was a really good kind of maturation of enterprise or of AI technology. Because once it gets under open governance, it's much safer for companies who want to invest in the technology to invest more, and for customers like Fidelity, I'm not saying they use VLLM per se, but to adopt it. And so now I think the core technology is pretty solid, both from a implementation perspective and starting to get there from a governance perspective, and now starting to see kind of a next adjacent set of technologies, like, of course, the agentic technologies, running AI models on the desktop with things like OLAM, et cetera. So it's just an evolution from just sort of the core nucleus of things that you need to these next layers out, especially focused on developer use cases.
Thanks, Bill. So I think what Bill said that was really interesting was open source. So all of us, or a lot of us, I should say, have been to All Things Open. And there's a definition for open source. And there's certain things like you have the ability to download and see the code, to make modifications, and to reshare it. But that's very specific to software. But when it comes to these training models, these frontier models, we use data to train them, and they become part of the model. We have, when you give it what's called weights and biases to the model, you're actually sort of tuning it with giving more weight to certain data than other things. So it makes it really interesting on how you describe what's open for these models. So our next segment, we're going to talk about open source AI. And I think the problem is that we have this thing, open source. We know what it is for Linux. We know what it is for Android, which is a variety of Linux, which wouldn't exist without those open source licenses. But how important it is, or how do we think about open source as we go forward? So I'm going to start with Fran, because she is a long-term open source committer for the Node.js project, and probably a lot of other things that I don't even know about. So what do you think about open source? What's your, as it applies to AI?
Super important topic. I really hope we don't get any vendor lock-in, because that would stall the competition and the progress. Like we just heard, open governance, standards for the APIs. I think that's really important so that people can switch out the underlying model. I think in most cases we won't be able to get fully open source models, but at least I want us to be able as an industry to easily switch vendors to go to the best model and to allow others to build models and not just be locked out by everyone else. So I'm excited to see where we're getting and how things are standardizing.
And then, John, in academia, how important is it to have access to this open source technology for research and development, for your students' accessibility? I mean, in the early days, Apple was notorious for giving cheap PCs to students to get us hooked. But now I think open source infrastructure is widely available. So.
Yeah, it's very important to us in kind of on kind of two aspects. One is education, and second is research. On the education side, which is where I spend most of my time, I teach our large language model class. I may have one or two students in that class here in the room. We actually have our students work with open models and do things like fine-tuning models. We don't have them training their own model from scratch might be a little much, but we do have them do fine tuning of models. That's just stuff you're not able to do with sort of proprietary closed source models, and so for educational purposes, there's tremendous value in the open ecosystem of models that we have, and the ability of students to get in there, kind of dive into them, understand how they were built, understand how to work with them, how to adjust them, fine tune them. Et cetera, and how to run them themselves on infrastructure. And then on the research side, it's also very important. We went through kind of a bit of a scary time the last couple of years in the NLP research community and academia, because a lot of folks who had been sort of spent their career in research in that area all of a sudden were sort of felt like there wasn't much to contribute because they didn't have millions of dollars to invest in GPUs to go train their own large language models, and so they just weren't able to keep pace with some of the frontier labs out there building models, and so that's concerning because I think academic research historically has been a key driver of AI progress, and the good news is that I think that is now changing as costs continue to come down, as we find creative kind of new architectures which are much smaller. It has started to become feasible again for university researchers to participate in research around large language models and not just kind of looking at the outputs and trying to identify bias and that kind of thing, but actually meaningfully, making meaningful contributions to new architectures as well by building them and training them from scratch. I think there's some news, like maybe yesterday out of Berkeley, a team trained a reasoning model that had sort of roughly equivalent performance to the O1 preview from OpenAI. On some benchmarks, and they did it for like $450, extremely cheap. So those are some very encouraging signs that sort of we're sort of starting to open up AI research again to not only to kind of a very small number of frontier labs to participate in, but to a much broader group of folks, which I think is great for the industry.
Yeah, great. So I think Fran had mentioned it, but it's really important, in my opinion, as someone who's built large infrastructure across, who's hung out with people who built it. I didn't build it myself because I'm not smart enough, but we did build early infrastructure around ISPs, cloud computing. I was an early executive at cloud.com, which was an open source cloud platform, and we couldn't have done that with all the open source tools that were out there, things like databases, things like Linux, things like, the Zen hypervisor and KVM, and things that a lot of you folks use today. I think an interesting perspective would be what Bill is doing at IBM. And I don't want to pit, one model against another. I do like to troll Mark Zuckerberg because he's very open source and he's sort of fast and loose on his definition, but that's me personally. What I would like to do is hear how Bill works at IBM on a frontier model called Granite, and how you package it and how you put together how you look at how you deploy and not deploy, but distribute that model to the industry.
Yeah, sure. So Granite is actually a family of models with different sizes, from 1 billion, 8 billion, 30, on up, and also different modalities, language, code, time series, even geospatial data. So it's really a family of models, and it was actually about this time last year that we decided that we were going to fully open source the family of Granite models under the Apache 2.0 license. And it was really, for a lot of the same reasons that we were big proponents of Linux back in the day, being an open source operating system. It seems like there's people of different ages in the crowd, but there was a time where it was considered kind of crazy to use an open source operating system for anything serious. And these days, it's kind of the opposite. Like nobody would, deploy a large number of systems and not use an open source operating system. And so our thought was things could go the same way with models. With operating systems that started from a very proprietary base with Windows and the various versions of Unix. And then over time, the open source operating systems became the things that were ubiquitously deployed. And so we made the Granite family of models open source under the Apache 2 license because IBM sells to enterprises. And for enterprises, the Apache 2, not just enterprises, but for our customers, enterprises, the Apache 2 license is really important because if you think about what a generative AI model does, it's, producing new content. And with that permissive license, we can help the customer be sure that they'll own the IP that's generated from that model rather than, there being some sort of made up license with some clause in there that we somehow own the IP. So we were trying to make it as safe for models, open source, as we now kind of take it for granted with normal software. But of course, the only reason we can take it for granted was because, pioneers 25 years ago worked really hard to create high quality software in communities under different types of license that people could safely adopt it, have success with it, and create that virtuous cycle.
So, yeah, and I think that's a really good point is, we are really, I hate to say that, standing on giants things. We're just standing on progress as we get to AI. We couldn't be where we're at today without things like the x86 processor and later the almighty Jensen and his GPUs from NVIDIA that became famous because we were all gamers. The internet, open source licensing, all of this sort of foundational stuff leads up and enables us to get to the point. Because AI has been around since the 1940s, I think, is when it was coined. And it's really been a long, slow road. And then the last 2 years, ChatGPT came around and bam, everybody is AI everywhere. So that's where we were. Our next section, we're going to start with a couple predictions and where we think what's going to happen this year with virtually any topic related to AI. So I'm going to start with Sachin and see if he has any thoughts on what's going to be interesting this year.
Sure. I think probably everybody has heard about agentic AI. Raise of hands, agentic AI.
Yeah.
Anyone? I think it's given that is coming, and obviously there is going to be, like what happened with Gen AI, a lot of agentic AI washing is going to happen. Everything will be called agents, but there is a specific definition of agents. But I believe that the promise of Gen AI and the ROI from Gen AI, I think the potential of us getting the ROI from Gen AI it will be through agentic AI. So I think that definitely is one. Second, I think is I think a lot of progress is going to happen with the reasoning model. So we just referred to it, and I think there's going to be more and more reasoning, and agentic AI depends on the progress made in the reasoning model. The better the progress, we are going to have much better agentic AI implemented. So those to start with as predictions.
Yeah, great. Let's go to Fran. Do you have any predictions for us this year, Fran?
I would love to hear what the audience has. Is this on? Is this on? Okay. I would love to hear what the audience has to say for predictions, but we probably have to save this for one-on-one after the panel. I'm also very excited about seeing more with agents. We've had LLMs talk to us for the last 2 or 3 years, and I bet some of you are a little bit fatigued with yet another chat app. But agents is where we get them to actually do stuff for us. So that would hopefully free up some of your time to do more interesting things rather than just get talked at from the LLM. Yeah, but I want to talk to everyone afterwards and be like, what are you excited about?
In our next segment, we're going to do questions. So if anybody wants to give their prediction during that, we'll entertain some of them. Let's go to John next. Like, what's the next step, or what do you think is going to be cool that not everybody has seen?
Yeah, I agree with what Sachin said around agents. I think that we're in sort of the very beginning of this really interesting transition from kind of LLMs being a bit of a fun toy to play with and kind of a helpful sort of assistant by your side to kind of get quick answers to things, to all of a sudden they're starting to do real work in the economy for companies. I run a startup, and it's been fascinating. to be in this place, because as we think about kind of growing our startup, now one of among the many things we have to think about, one of the things we are thinking about is when do we add AI agents to our team versus when do we add human people to our team to do certain things, and so there's some really interesting systems emerging in areas like customer service, areas like some aspects of the sales process, kind of the early stage, lead generation, lead qualification, et cetera, where AI agents appear to be doing a pretty good job. And so, you start to look at the economics of hiring an agent to do those things versus hiring a person. And there's a lot of great things about AI taking on some aspects of work. To be very clear, I think there's a tremendous number of things that humans can do that agents cannot today, and maybe never will be able to. But there are starting to be certain either whole jobs or portions of jobs which I think can be are being taken over by agents, and I think that trend is going to accelerate throughout this year. We're going to see that show up sort of more and more. I think for companies the cost savings and sort of the productivity gains are almost irresistible in some areas.
Okay. Before we get to Bill and the big finale, just to dive into agents. The idea around agents are they're objective based. So when we type into ChatGPT and get that question and answer, that's different than when you say to an agent, complete this task. And the limitation today is the ability for these models to reason. The reason that OpenAI's O1 model was so interesting is it starts to bring reasoning into the equation. And one of the things that they also do is we've been seeing better results by making them think longer, sort of like us. If I give you a quick answer, I may not be nearly as thoughtful as if I took my time and gave you a more thoughtful answer. That's aspirational because I probably still give you the same dumb answer, short or long, but that's the AI models work. So right now, the big sort of gotcha or the sticking point is the ability for them to reason. So if you look in the spectrum of in artificial intelligence today, I like to start with sort of the first sparks are when IBM's supercomputers started to win Jeopardy. That's like the beginning. Today, we're starting to get to the cusp of what I like to call the R2-D2 C3PO, where these things are starting to make us think that they're probably going to be pretty close to human, but they're going to be in parity with us. So, artificial general intelligence means that they would have the same capabilities as a human. And then we have what we call the Agent-Smith matrix part, which is super general intelligence. And that's the one that can be great. It could solve cancer or put us all in pods and live off our fluids. It's a 50-50. I actually like to think of it as they're going to solve cancer, but those are sort of the spectrums. But when we talk about agents being, replacing jobs, I think what we're going to see is that we're going to be orchestrating teams of agents that work for us. Like, there is no value in me getting rid of responding to all the stupid inquiries that I get in my inbox from people who I don't want to buy stuff from. Eventually, I'll be able to train an agent more nuanced than what you can do with filtering and spam filtering today. Or I will have it do certain things like fill out expense reports, make travel plans, things like that. You're still and they're gonna have agency. They're gonna be automated in small, discrete tasks in the short term. And in the long term, there'll have teams of them. So I think what'll happen is, more than likely in the short term, we will be managers even if we're individual contributors. So I just wanted to stick that in there before we go to Bill. Plus I gave him a couple more minutes to come up with something really awesome. So he could have the final word on what he thinks is in the future for 2025.
Yeah, so I'll make two predictions, one unhappy and one happy. So the unhappy one is, I think there will be, not from anyone on this stage, but some pretty high-profile disasters with generative AI this year. And the reason for that is, if you think about the timeline, ChatGPT was November 2022. 2023 was really a year of dabbling, like everybody was doing their ChatGPT for X. And it was only last year that people started to do real production systems. And it's really only this year that you're really starting to that web app used Gen AI, or that mobile app used Gen AI. So it's actually starting to get used in real world context versus just, demo apps. And a lot of folks out there are really focused on what they can make kind of sort of work without thinking through all of the implications, security, trustworthy, et cetera. So I think, and this happens with any new technology. So I think there should be some pretty high profile disasters, hopefully more on the embarrassing side than the harmful side. And then after that, people will, talk about, let's have more lockdown governance of our AI at our companies. Let's accelerate the regulations, et cetera. Then the happier one, I'm a real software engineering nerd, and my original team lead 20 years ago was a guy named Eric Gamma who wrote Design Patterns book, a lot of people own, if not read. And I think one fun thing that's happening now, like this last year or two with AI, is that we're starting to discover the design patterns for generative AI, with the kind of the first one, in my opinion, being the retrieval augmented generation pattern, RAG. A year ago, everybody was like, oh, RAG, it's so cool. Now it's like there's 20 different frameworks for it. And so I think we'll start to really see with the web, people find things that work, and then they get encapsulated in patterns, and then those become libraries and frameworks. And once that happens, then you see a real acceleration of actually useful applications, because you can focus more on the applications versus the plumbing.
Great. Awesome. I have two myself. So the first one I have is about robots. So I think that, robots. I think that it's a robot that's clapping. I like that. So I think one of the things that's most interesting about what's going on around AI today are the self-driving cars. If you've seen Waymo in San Francisco, it's amazing. There's no way in hell 2 years ago I would have gotten a self-driving car. Today, I think I'd do it before I get in with the shady Uber driver that smelled like weed that picked me up last time I was in San Francisco. But anyhow, I think that there's a couple things around that. Is we talked about the training data that goes into this. I think that we're collecting more and more of this data. There's more and more data sets, because for these things to evolve, they've got to have visual data. They've actually should have touch data. So I think what's Tesla's big computer or robot? I want to say it's Megatron, but it's definitely Optimus. Sorry, wrong side of the robot intergalactic war. I think fusion, what these folks are doing, are really, really interesting, especially for things that are dangerous. Like I was telling someone earlier, I had every crappy construction job as a kid going through college, and I think that's one thing that this year we're going to start seeing. I really think there's a lot of robotic stuff that is going to start becoming real. And the thing that's interesting about Tesla and them doing it is they've been collecting lots and lots of data through their cars for years, and they have all this manufacturing data from cameras and sensors and such. So I think that's one place that'll be good. The other thing is, my first job was at the beginning of the internet. So I was on the phone at an internet call center in 1995 or 96 when Yahoo came online. And Yahoo was a huge jump forward in the search engine space over, before that it would have been like AOL web crawler, and it didn't work quite the same. And everybody thought Yahoo was the greatest company, it would never get dethroned. Well, today Yahoo is a subdivision of Verizon, I think, and Google came along. So my prediction is, even though OpenAI started out in this juggernaut in the space, that we're going to see a lot of folks like Facebook and Google. I really, in my newsletter today, I talked about some of the cool stuff that Google's doing. I think it's not going to be an industry where OpenAI is as dominant as they've been for the last 2 years. And I think that's good, because it gives us choice. So those are my two, and not just because IBM and Google are on the panel, I'm not kissing up, but I do think that it's going to be a more democratic AI landscape. So that ends us talking to you. Now you get a chance to talk to us. So I don't know if Todd or Jason has microphones out there, but if you have a question for the panel, and I will have, is Todd here? He got us all in a room, locked the doors, and ran away. Gas will be coming in shortly. So,
We can probably give you.
yeah, why don't we, yeah, if you don't mind, Fran, you can hand the mic. See, that's why she works at Google. She's super good at problem solving.
But I can't turn it on, so.
All right, if agents start doing all the kind of low-end, early engineer stuff, where do you get early engineers now? Because all of a sudden you have managers. Like everybody has to start off as being a mid-level engineer, and if you don't do the basic stuff and make those mistakes, you can't get there. When I think about tenuring and career laddering, this idea of agents or any kind of concept coming at the low level and replacing the low-level work creates its own problem. Not tomorrow, but from a year or two from now, you had this missing part of the career ladder.
Volunteers? That's a tough one.
Yeah, I can.
Sachin will take it. Awesome. Go ahead, Sachin.
So I have a different perspective of this whole thing about AI replacing and all, right? So, I mean, we all have heard that it's not AI replacing humans, it is humans who know AI replacing, right? So, I think, my personal opinion, I think we are going to go through this disruption wherein we are going to be in this mode where we'll have to really upskill and train people to use this new technology, and to maybe they get into the mode of really orchestrating AI. But I don't believe the fundamental skills of that a software engineer does, which is much more than coding, is going to go away. So again, because I'm always applied AI, so it is all about like understanding the requirements, use cases, implementing according to those, be able to debug and all, right? So it is I think the way I think is whether it is the use case of a developer, use case of a backend operation associate, I think it is all going to be that the repetitive tasks are going to be done, but you still need to understand what's happening behind the scenes and be able to orchestrate and then figure out when things go wrong. You know, so.
Awesome. Anybody else want to take a shot at that? I like where you went. All right. My man in the center there in the gray shirt has the mic.
Yep.
Okay.
Hi. I have a question about the philosophy and the ethics of training these LLMs, because if whatever is being inputted right now and directed for the development of the machine learning process, that is going to dictate the final outcome of which direction and vector an LLM is going to take. At which point in, let's say, if we're talking about different industries, let's say economics, right? What kind of philosophy and ethical principles are being deployed with the development teams that are training these AIs are being taken into consideration? How is that being taken into consideration between different philosophies, different cultures around the world? Because right now, US is dominating, obviously, the scene of AI development. So.
So not softball questions tonight. Yeah, another great question. Yeah, so certainly the data that an LLM is trained on will have a huge impact on its ability to produce reliable outputs. And so there are a lot of critically important decisions to make, when you're building an LLM in terms of what you're providing in the training data, what you're providing and what you maybe decide not to provide also. We know that kind of in the early LLMs, they're filled with, for example, all sorts of different biases, right? And a lot of that resulted from the data that was being used to train it. And over time, I think there have been improvements in trying to reduce the bias, in part by removing training data. synthesizing training data, for example, to sort of counterbalance natural, or I shouldn't say natural, to counterbalance biases that are sort of inherent in content that's available online for training. And so I think we've made good strides there in terms of reducing toxicity, reducing bias. To me, actually, so part of it is sort of decisions around what to include in training. Maybe even more important factor is in some of the post-processing that gets done during training these LLMs. So, as many of you know, they're trained on these massive quantities of data from mostly from the internet, right? But then after the initial training is done, they go through a couple of other phases of training, what's called supervised fine-tuning, and then another one that's called reinforcement learning with human feedback, or some variant of that. And it's actually during those two post-processing stages when the model sort of learns its sort of behavior in terms of how it decides to respond to things. And there are good opportunities during those stages to try to further reduce toxicity and bias. But that's what generally the idea is to do. But those are processes that are largely guided by humans. And so when you have a critically important step like that that's guided by a small number of humans, it raises questions around who are those humans that can make those decisions, right? Where did they come from? What country are they from? What religion are they? What values do they hold? And so I think, at least in kind of the early days of LLMs, that there was no transparency on that. Really, no, we didn't know. I think that's gotten a little bit better, but I think ultimately there are kind of two different maybe possible paths, right, that you could take. One is to have a very broad and diverse group of human stakeholders participating in that process to try to align on kind of a common core set of values that we want these models to uphold, that are sort of more or less consistent across national differences, cultural, religious differences, et cetera. That's one alternative. A second alternative would be that we end up with different versions of models which are sort of tuned to different sets of values. For example, maybe there's a model tuned towards specific nations' values, or specific religions' values, for example, and so you may choose to use that one, or you may choose to use another one that's tuned towards a different set of values. So I know it's a fascinating question, kind of which of those two directions we might go. I think the answer is not at all clear yet, but those are the two avenues that I see right now.
Just to add briefly to that, I think I see a lot of parallels. I come from a traditional software background with kind of the evolution of the maturity of security in traditional software, with the evolution of trustworthy AI. And, in the bad old days when lots of people were really bad at security, the approach was, at the end, when you're done building the thing, you say, okay, now make it secure, which of course is a recipe for disaster. And so it takes a whole life cycle approach. And so I just add to what John said, everything that I agree with is it really takes a whole life cycle approach, starting with, problem definition, use case definition, and the demographics of the users with whom you'll do user research, which should be representative of your user base, all the way to training, data collection, model building, model testing, deployment, et cetera. And I think the other thing is transparency throughout, and the expectation that despite your best efforts, problems are going to happen. So be ready to respond to those when they do happen, and transparency happens with that, or helps with that as well.
Awesome. And John, if I took your class at Duke, since I don't have the tuition money, there is a test around bias that machine learning folks have used before. So we have a measurement, though it's probably not the same kind of bias as we talk about when we're talking about personal prejudices. What's the score called? Do you know what I mean?
There's a couple of different bias data sets. Yeah. I don't remember the names of them.
Okay.
Yeah, there are a couple of different ones. Obviously, there's all sorts of different types of biases, and so there are a few different ones that you can use. There's a fascinating paper actually from Apple, I think it was maybe 6 months or a year ago, that was published looking at, for example, gender biases in outputs of LLMs, and they showed that they not only exist, but they're very prevalent in the responses. And so one of the assignments, actually, I'm going to spoil this for any students that are in the room, but one of the assignments we do in our LLM classes actually have the students identify something like that, like a particular, let's say, gender bias, for example. Come up with a way to measure gender bias of an existing LLM, usually a small open source one that's kind of manageable, and then see what they can do to improve it. And so that can be, there's a number of things you can do, usually involve some sort of post-processing, some additional fine-tuning or reinforcement learning, but they actually have an opportunity then to kind of learn the process of here's how, one, how we identify a problem in an LLM today, and then two, here's how we can actually do something that actually can resolve, or maybe not fully resolve, but at least help to mitigate that problem.
And I didn't mean to put you on the spot, but there are tests out there that are not perfect, but the idea is it's of high concern, and there's certain measurements. I think the best thing will probably be human judgment and the people that are building them, like building that in, but as my parents will attest to, not all human judgment was good through their lifetime. But we have another question.
Mark, can I just add one quick thing?
Oh, yeah, sure.
There's a resource that we worked on that I'm pretty proud of. It's a free documentation resource called the AI Risk Atlas. And what it does is look at the various risks that tend to occur with the deployment of AI systems, and in very simple, language, how to understand those risks and how to try to mitigate and avoid those risks. So I definitely check it out, the AI Risk Atlas, and it's a very comprehensive set of risks. I mean, of course, bias, but much more than that.
There, it's a very flat little.
Sorry, I figured it took me a second to get the button working. I didn't want to mess with it. The question I had for you guys might be a little bit two-part. I come from a cybersecurity background, so my brain is naturally already skeptical. But I was going to say, when talking about not just the biases, but also the way that truth or accuracy comes into effect. My question is, when you have tasks that are not something that can be solved a bunch of different ways, but something where there is a right answer, what I've seen so far from AI is it has a very non-deterministic, it will come up with different answers over time as it's been trained based on what it's been trained on. From a security perspective, that means it's not as predictable, and usually you use anomalies as the way to determine what is safe or normal and what is outside the baseline. When your abnormality is your baseline, it's a two-part question. Are there places where AI doesn't meet the accuracy threshold, the ground truth piece? And then secondly, is there a good way from your experiences to measure those abnormalities? What is too weird, and maybe there's something wrong with my LLM versus what is within the bounds of a normal standard dev of the answer? Does that make sense? Did I throw a lot of words at you? I'm sorry.
Thank you for that. I'll start. And so my personal philosophy in terms of using LLMs is I never use an LLM for anything where it's going to be a problem if it gives me a wrong answer. So that means I only really use LLMs kind of, so I say, out of the box, like ChatGPT through the website or something, for like what I call very low stakes things. So if I'm coding and I need a quick kind of help with something, like I'll ask it, right? But if it's wrong, it's just 5 minutes of extra work. It's low stakes. It doesn't matter that much. But so versus, let's say, a high stakes thing, if I'm writing a research paper and I need to kind of find a source for something, right? And this is a common mistake a lot of students make, is like, even faculty, honestly, I was talking with a professor the other day who was asking me about this. They'll like ask ChatGPT for kind of an answer supported by sources, and it will give you that, and half the sources will be completely fictional. So never do that, by the way. So I always assume that there's a high probability that I'm going to get the wrong answer when I use an LLM out of the box. Obviously, it's gotten better with time, but it hasn't gone away, and I'm not sure that it really ever will go away. So that's why, as Bill mentioned, RAG, retrieval augmented generation. I'm a big proponent of that. That certainly has limitations too. We can talk about, but it's much better to use this type of a thing versus an LM out of the box. For those of you that aren't familiar with that term, what that means is basically. When you ask an LM a question, the first thing it will do is perform a search for relevant information to answer your question. And so you have to kind of give it places to search. It might be searching the web. In the case of like what we do with my company Inquisit, we search research papers, right? And we try to find answers in research papers. It might be searching like your enterprise systems. And it will try to find relevant information, and then it will answer the question by synthesizing the information that's found, as opposed to just trying to invent an answer out of itself. So that tends to result in much more reliable responses, much lower risk of what we call hallucination or making things up. Again, it's not perfect. There are more advanced versions of that are coming out, which are further helping. But I suggest always trying to use that type of an approach whenever you have anything that's not just a simple kind of low stakes question that you have.
Yeah, and also if you have something deterministic, don't make the LLM answer it. Like you can configure your LLM for all the deterministic things to use a different function. Like say you have something weather related, you can have the LLM handle all the parsing of the question and phrasing the answer, but it would use an actual weather API to make the weather. And you can help a little bit with the right prompting, do the whole don't hallucinate, only respond if you do find it in the RAG material we gave you. But yeah, good question. It's not secure, and we will find problems.
All right, we have time for one quick question. So
Thank you for the opportunity.
Sure.
So I'm I'm a program manager at Cisco, and he's a development lead at Cisco. So what we want to know is those who are having like 10 years, 15, 20 years of experience. We started from C, then Java, then .NET, then MERN, all different technology stacks that we work. Now, suddenly everything is OpenAI, Gen AI that's going on. So how do we ensure that we are competent still in this cutthroat scenarios that are there? And what upskilling or learning paths we should focus on so that the job is safe?
It's a really good question, and I believe that I think, in my opinion, if you're looking to onboard to Gen AI and this whole AI hype and all, don't become an AI expert. I think becoming an AI, having a goal of becoming an AI expert, I think is a wrong, in my opinion, is a wrong goal. I think becoming a domain expert with augmenting it with understanding what these technologies do, the limitations of these technologies. The previous question, it clearly talked about like if it is deterministic, LLM is the wrong tool, period. There's like you need to just think of some other ways, right? So I think learning particular domain, and then augmenting it with AI literacy, knowing when to use, when not to use, the challenges, limitation, etc. I think is the right way to go about.
I'll just add one last simple thing. If you focus on user value and solving useful problems, you'll still be ahead of 95% of people.
Thanks.